Hello and welcome to this video. The lesson aims to introduce us to PLC programming with TIA Portal. Today we are going to see how to write a PLC program in TIA Portal for direct motor start. As we know, motors are widely used in the world of industrial automation. One of motors' applications is conveyors. A conveyor is run by a three-phase motor which is energized by the PLC output through a contactor or a relay. Well, prior programming and automation engineer needs to understand well how the system works, then it's better to identify our inputs and outputs before moving to programming. Accordingly, for our case, we have two push buttons as inputs, one for starting and the other for stopping the motor, which is the output. Along this stage of the course we are going to acquire a solid knowledge to move to the second level of PLC programming. After having set up the TIA Portal software, we click on the icon here to start programming. Once in the software, we click on New Project and give our project a name. In the box up we enter an appropriate name for our project, then we click on Create. It takes some time before it loads up, it depends on your computer's performance. We're just getting started. Even if we click now on Write PLC Program, we cannot start programming. We need the so-called material configuration. Well, we can now choose the right PLC for our process by clicking on the little icon here. From the controllers menu, we select a PLC. In a real-world application, we select a right PLC according to the serial number of the physical PLC in hand. The serial number is generally found on the back of the PLC. Thus, when adding a device, its serial number shows up underneath, and in the description below it is shown the whole features of the selected CPU. Here is the serial number, and in the description we can read the features of the CPU. The primary feature to consider, as you can see here, is that we have a compact CPU and integrated digital input and output modules. Definitely, we are not going to focus on the whole features, it is out of today's scope. This is fully explained in a dedicated lesson. Now, we can access the main OB, TIA Portal programming interface. It is the main organization block and it is executed from the PLC processor, that is the CPU. Before we can start programming, it is crucial to check out some parameters and bring some modifications if necessary. In the device configuration, we click on the device we want check and then on properties. For instance, here the addresses of the CPU modules, both of them by default start from byte 124 and end in byte 125, that's 16 digital inputs and outputs. We have the choice to modify them or let them as they are. However, in case we upload the material configuration to the physical CPU, the addresses of the inputs and outputs used in the PLC program must be the same as the ones here, otherwise our CPU could run into an unnecessary fault. Consequently, even if we work with PLC sim, we act as if we were dealing with physical devices. Well, for the sake of not making things complicated, better we work with the byte number 0 and 1. So we modify the address for both of inputs and outputs. Perfect, we are done with the addresses. Now you can see here next to the CPU there are slots for additional modules and other devices that we can add from the catalog on the right. Of course, that depends fully on our industrial process. Everything is okay now for us to start programming. However, a point not to put aside in PLC programming, it is organization. For instance, once the inputs and outputs are identified, better we enter our inputs and outputs from the beginning. We head on over PLC tags, and in the default tag table we can insert the whole inputs and outputs. This will result in a practical and tidy program. As it has been pointed out earlier in the course, the inputs and outputs in TIA Portal are represented respectively by the letter I and Q followed by the byte number. Bit number. For more information on the topic, we have put the link of the video about PLC memory. Check the data type part. Once we are done with the material configuration and the identification of the inputs and outputs, we can now move to programming. We open the main OB and start our program for motor start. We drag from above an open contact for the start push button, a closed contact for the stop push button, and coil for the motor contactor. We assign each symbol an address and move to simulation. Clearly, as we have already inserted the inputs and outputs, the name of each shows up just typing the first letter of the tag. The program as it looks, is able to run the motor as long as we use a switch. However, we have a push button. Still, we simulate the program as a way to explain the technique we would like to show you in this lesson. Before the simulation operation, better to compile first the program to check any programming mistakes. Then, we click on the icon showing a computer and follow the steps to establish the connection between TIA portal and PLC sim, in other words, to simulate the program. We wait until this window appears, and from here we select MPI. The MPI just one interface among other communication protocols we use with the physical devices to establish communication between the elements of the PLC system. Clearly, if there is no issues, we won't have much trouble reaching the targeted device, just clicking on Start Search. Then we click on Load to load the PLC program data from TIA portal to PLC sim. Finally, the communication is established, so we can start simulating our process. Now we move to PLC sim. We click on Run P to launch the simulation and on the glasses icon to visualize our process running up. We press on the first input and normally the motor turns on. This program remains valid as long as we use a switch. But as you know, we used a push button. As a result, the motor deactivates when we release the push button. To fix this, we use a latch. To make a latch, we insert a branch and an open contact and assign it with the address of the output we want to keep energized, in our case the motor. We compile the program again for eventual mistakes, then we load the modifications to PLC sim clicking on here. Perfect, no issue reported. We launch PLC sim and test the modified program. Now you can see that even if we release the push button, the motor's still active. Now if we want to turn the motor off, we need to press on the stop push button to cut off the power to the outputs. A critical point to add over is that if we need to energize the output again, we need another press on the push button. The program as it looks ran well, however, whether we want or not, there is something missing. It concerns the stop push button, if the physical push button used to stop the motor is a closed contact. This results in an imperative modification in the program. To simulate our case, we use an open contact for the stop push button, but before starting the simulation, we head over PLC sim and press the stop push button. This means that the stop push button we used is a closed contact. PLC sim, also called virtual CPU, a fundamental point I would like to show here is that to be able to simulate our program, we need to make sure that we have well understood fully how process should run in order to first to come up with a program with least errors and then making the right simulation before we load to the actual CPU. Let us test the new program and see how it works. As you see, the program ran the same way, the only difference is in the contact used. Hopefully, you have got well the idea. Thank you for watching the video. Now if you find the video interesting, make sure to subscribe to Step Plus on, give us a like. See you in another video. Bye.